number systems. So in this lesson we will be discussing about the important concepts in number systems, and we will also be solving a few questions. So first, there is one quick flow chart. Let's see that. Real numbers consist of irrational numbers and rational numbers. Rational numbers consist of integers, whole numbers, and natural numbers. Natural numbers are nothing but counting numbers, right? They are counting numbers, 1, 2, 3 till infinity. Integers consist of negative numbers and whole numbers like -1, -1, 0, 4. These are all integers. Whole numbers consist of natural numbers, that's 1, 2, 3 and so on, and 0. So all of you will be knowing this. It's a quick flow chart. Now numbers. Now let's revise or look back into what we have learned all about numbers and what we will be learning about numbers. So first, starting with natural numbers. As we have seen here, natural numbers are nothing but counting numbers. Natural numbers are positive numbers, that's 1, 2, 3 and so on. Natural numbers are positive integers. In other words, you can tell counting numbers. They are counting numbers. Yes, they are counting numbers. Now next, whole numbers. Whole numbers are represented by W. Natural numbers are represented by N. Okay. Yes. So natural numbers N, whole numbers W. Okay, whole numbers are 0, 1, 2 and so on. Whole numbers are natural numbers. Please note it. Whole numbers are natural numbers including 0. So whole numbers is natural numbers plus 0. Whole numbers do not include any fractions, negative numbers or decimals. Yes, just quick look back into what we learned all these years. Now next is integers. Integers are numbers that include whole numbers and negative numbers. So whole numbers plus negative numbers is integers. An integer is a number from a set of negative and positive numbers including 0, which has no decimal or fractional value. So integers examples are -3, -2, 15, 900 and so on are examples of integers. Z is the symbol for the set of integers. So integers is Z. So here you can see integers number line. So from here you have positive integers. From here you have negative integers up to infinity, and here up to infinity. 0 is neither positive nor negative. Yes. Now next, numbers. Rational numbers. P by Q form, where Q is not equal to 0. Yes, a number R is a rational number if it can be written in the form P by Q. If it can be written in the form P by Q, where P and Q are integers and Q is not equal to 0. Examples are 3 by 5, 7 by 2, 11 by 13 and so on. Yes. So rational numbers are represented by the alphabet R. Yes. Now next, this is the actual concept of number systems. Irrational numbers. Yes, we will be giving more we will concentrate more on irrational numbers in this particular number system chapter. Now, any number that cannot be represented in the form P by Q cannot be represented in the form P by Q, where P and Q are integers, Q is not equal to 0, is an irrational number. Examples are root 2, e, pi. Yes, irrational numbers are any rational number that cannot be expressed in the form P by Q. Yes, that's it. So numbers, natural numbers, whole numbers, integers, rational numbers, and then irrational numbers. Yes. Now, representation of numbers. Representation of numbers on the number line, especially real numbers. Now, real number consists of rational numbers and irrational numbers. Yes. So, from here it is natural numbers. From here it is whole numbers, and together it is integers. This is also rational number. So you can see between two integers you have rational numbers, and yes, you have irrational numbers also. This is an irrational number. But see, is root 49 an irrational number? No. What is root 49? Root 49 is nothing but 7, right? 7 is a rational number. How? Rational numbers are expressed in the form P by Q. So 7 by 1. Yes. Simple. We already learned in the previous classes, right? A piece of cake now. Now next is the representation of irrational numbers. Irrational numbers. Representation of irrational numbers. On the number line. Irrational numbers. So now if I ask you to plot root 2 on the number line, what would you do? First, take 2 and express it as a sum of 1. So 1 plus 1 is 2. Now if I ask you to plot 5, root 5, then what would you do? Definitely there should be plus 1. So a number plus 1. Yes, so it will be 5 is equal to 4 plus 1. So root 5 will be root 4 plus root 1. This is a trick I use. So root 4 is nothing but 2. Root 1 is nothing but 1. So root 5 will be equal to 2 plus 1. Yes, now let's discuss this first. Now 1 will mark 1 here and 1 here. So the triangle formed hypotenuse will be root 2. So now you will take a compass, mark the point here and cut an arc such that this intersects. So this whole is root 2. Similarly, you will take for root 5, this is 2. So you will take this as 2 units, this as 1 units. So you will join with this, cut an arc, you will get this as root 5. Similarly like that. We will discuss this more. We will discuss this in detail in part 2. This is method 1. There are several methods in which you can plot irrational numbers. This is one easy method. This is one easy method. There are like I think so 2-3 methods are also existing. In part 2 we will discuss each of them in detail. Now real numbers consist of rational numbers and irrational numbers. Examples of irrational numbers: root 5, root 2, root 31, root 6. See, I have a question. Is root 36 a rational or irrational number? Comment it in the comment box. Rational numbers: 5 by 6, 1.5, so on. 1.5, how is 1.5 a rational number? 15 by 10, right? That way also you can represent. Integers, rational numbers, integers, then whole numbers, then natural numbers. The thing to be noted here is Natural numbers are whole. Natural numbers are whole numbers. Natural numbers are whole numbers. Natural numbers are whole numbers. And whole numbers are integers. Integers are rational numbers. I'll tell once again. Natural numbers are whole numbers. How? What is whole numbers? Whole numbers are natural numbers plus 0, right? Whole numbers are natural numbers plus 0. So natural numbers are whole numbers. What are now whole numbers are integers. How? Now what are integers? Integers equal to whole numbers plus negative numbers, right? Now integers are rational numbers. How? Take 0. 0 can be represented as 0 by 1, which is nothing but 0, right? So that is how. So it's like, you can take it as 0 by 1. So P by Q form, right? P and Q are integers. Yes. Irrational numbers do not come under the category of rational numbers. This is separate from this. Yes. Now we have arrived for the first question of the session. The first question says, find which of the following are true and which of the following are false and give reasons for your answers. Okay. Now first question is, every whole number is a natural number. See, think about it. What are whole numbers? Natural numbers plus 0. What are natural numbers? 1, 2, 3, counting numbers, right? And they do not include 0. They do not include 0. So they're telling every whole number is natural number. It's obviously false, right? Why is it false? 0 does not come under the category of natural numbers. 0 is a whole number. 0 is whole number, but not natural numbers. But not natural numbers. It is not a natural number. But the other way is right. Every natural number is whole number. I'm just representing with that alphabets, okay? Now next, every integer is a rational number. Yes. What are integers? Whole numbers plus negative number. What are rational numbers? Rational numbers are in the form P by Q, where P and Q are integers, right? So this is true. Second one is true. Why? Integers can be represented in the form P by 1. If you take the integer 2, you can represent it as 2 by 1. Yes, 2 by 1 is a rational number. P by Q form, right? Now next one says that every rational number is an integer. No, false, right? Second one is false. Why is it false? Tell me. It is false because take the number 3 by 4. Take the number 3 by 4. Is 3 by 4 integer? No, right? It's not an integer. Isn't integer, right? So that's why. Now let's discuss the answer. Yes. First one is false, as we have discussed, because 0 is a whole number but not a natural number. The second one is true because every integer m can be expressed in the form m by 1. The third one is false. Why? Just now told you, right? Any numbers, any rational number in the form P by Q except m by 1, every rational number except m by 1 is not integer is not integer. Yes. Say 3 by 4. It is not an integer, right? That's what we discussed in the previous slide. Now next, numbers between two numbers. Numbers between two numbers. Now I have a quick question. How many numbers are there between two rational numbers? You know the answer. You know the answer already because we have learned it in the previous grades, right? There are infinite numbers between two rational numbers. Yes, how to find these numbers? Let's see. There are two methods of approach. One by using the LCM method, two by finding the mid value or average. Now take 3 and 4, find one natural number between them. What do you do? 3 plus 4 by 2. 3 plus 4 is 7 by 2. 3.5, right? The midpoint will be 3.5. Now I'll ask you to find three numbers, any three numbers between 3 and 4. Now take this and this, 3 plus 3.5 by 2. Now you will get one value. Now take this and 4. So 4 plus 3.5 by 2. You will get one value. So that value will be here. So that another value will be here. So you have three numbers between these numbers, right? So 1, 2, 3. That's it. So that's how you will find by finding the average or middle value, a plus b by 2. Mean, you can also say it as mean, right? Yeah, okay. Now next is LCM method. LCM method, most of you will be knowing it. LCM method. So it's like this. So 3 by 5, 4 by 5 means to find it, the denominators are same in this case. So if I ask you to find three numbers between them, the thing is to just multiply them with 4 for the convenience of finding more numbers between them. 3 4s are 12 by 20, 16 by 20. Now you have many numbers between them, right? 13 by 20, 14 by 20 and 15 by 20. So these are the three numbers between them. So this is, in LCM method there are two methods, two ways. When the question when the denominators are same, just multiply it with the bigger number, so you get a number like this. Now what if the denominators are different? Say 3 by 5 and 4 by 7. So in this case you will take the LCM. Yes, 5 and you will multiply 5 and 7. Yes, 3 into 7 and 4 into 5. 5 7s are nothing but 35. 3 7s are 21 and 4 5s are 20. Right? So now this is the thing. Now multiply with a greater number. Find one number between them. So there is only 20 and 21. So in order to find another number, just multiply it by 2 and you get a number between them. So that's how you solve it. It's like we already learned it in the lower grades, and this does not need much, there's no need to teach much on this. Now the question 2 is find 5 rational numbers between 1 by 2 and 1 and 2. Sorry, it's not 1 by 2, sorry, excuse me, it's between 1 and 2. So recall that to find a rational number between any two numbers, you can use two methods, a plus b by 2, or you can do another method, right? LCM method. Like we saw two methods in LCM method also. So let's okay, now let's find using a plus b by 2 method. It's nothing but mean, taking the mean. So 1 plus 2 by 2. Nothing but 3 by 2. One rational number. So let's assume this is a thing. So this is 1. Sorry, this is 1. Assume this is 1. This point is 1. This point is 2. This is 1, this is 2. Between them is 3 by 2. Now as I said, 1 plus 3 by 2 by 2 will give you the next number. So this will come here. Now this will be the second number. Third number will be 3 by 2 plus 2 by 2. So I'll get another number here. Just like that, you can keep on divide and you can get the answer. Now take the point. Yes. Like that, you can just keep on going here. Yes. Shall we find this answer? Okay. Let's do it. So let's solve it one by one. So 1 plus 3 by 2 by 2 is nothing but 1 plus 3 by 2 into 1 by 2. So this will become 2 plus 3 by 2, which is 5 by 4, if I'm not wrong. 5 by 4, right? Yes. This will be 5 by 4. 5 by 4. Now next here, let's come to the third number. 3 by 2 plus 2 into 1 by 2, which is nothing but 3 plus 4 by 2, which is nothing but 7 by 4 is equal to 7 by 4. Just that, like that. Now take 3 by 2 and 7 by 4 and find one more number between them. Take 5 by 4 and 3 by 2, find one more number between them. So like that, you can keep on divide and get the answer. Now let's see LCM method. LCM method. So LCM method, see the denominators are same in this. So like this, denominators are same, 1 by 1 and 2 by 1. What did we do? In order to find 3 numbers between them, we multiplied with the 4 we multiplied the denominator with 4. So similarly, we are asked to find 5 numbers. So let's multiply by 6. Let me erase the background, so it will be convenient. So it is what is it, 1 by 1 and 2 by 1 multiplied by 6. 6. So you'll get it as 6 and 12. Between 6 and 12, you have 7 by 1. Okay, 7 by 6. 6 by 6 and 12 by 6. 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. So another set of numbers you have got. So 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. All are valid. This is also right. This is also right. Now question number 3. Find 5 rational numbers between 3 by 5 and 4 by 5. So we already saw this, 3 by 5, 4 by 5. To find 5 numbers, multiply with the next numbers. So it will be 18 by 30. 4 6 are 24 by 30. So you have 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. Yes, 1 2 3 4 5. We got 5 numbers between these two numbers, right? Let's move on. I think this is the end of part 1. Thank you. Have a nice day.